Myself, Dr. Sateesh Nagavarapu. I'm the professor in Department of Computer Science, Engineering and Data Science. Today I'm going to give the presentation on in the subject of AT&CD, that is Automated Theory and Compiler Design. The foremost topic here, I'm going to recall the concept of Arden's theorem and even the second method called as the state elimination method, and how to convert the finite automata to regular expression we are going to cover in this AT&CD, the topic. The first foremost topic is how to convert a finite automata to regular expression. Today we are going to cover that. The first foremost Arden's theorem. There are two things you need to remember. One is when you go with an Arden's theorem, we need to have the first is equivalence. Two regular expressions should be equivalence, and second is automata theory. Finite automata theory, you need to convert it into regular expression. There are two conditions. Finite automata should not contain any epsilon, first point, and finite automata should not have only one initial value. It should not contain multiple initial values. That is the second point. And what is the Arden's theorem defines? How the Arden's theorem states? Let us assume there are two statements, two regular expressions, P and Q, are said to be two regular expressions over an alphabet sigma. If P does not have any epsilons, then the equation will be R equals to Q plus RP, which will have a unique solution, that is R equals to QP star. Right? Here we are going to derive for each and every example, we are going to convert the finite automata to regular expression. Let us assume there is a finite automata which contains some Q. Q contains Q0, Q1, Q2, and input alphabet of A and B, and the transitions of the Q0 there is in a B and even A. For Q1 only A and Q2 only for A. Let us assume when you go for an Arden's theorem for converting finite automata to regular expression, these are three things we need to remember. These are three steps we need to remember. First is, for every state we need to identify the equation. For each and every state we need to identify the equation based upon the incoming edges. Based upon the incoming edges, we need to define the whatever the equations. Second is, we need to add epsilon for initial state. We need to add epsilon for initial state. Third step is, we need to simplify the equations. One, what are the Q0, Q1 and Q2, and we need to derive the final state of the regular expression by taking as a final state and by using the Arden's theorem where R equals to Q plus RP, which derives the R equals to QP star. This is an Arden's theorem, how we work. Let us go with this when we are working on this. Let us go with simple statement. I'll represent with how the statement will work. Let us go with Q0 equals to epsilon, first statement, because it is the first equation we are deriving. This is the first equation. Let us assume this is the first equation. Let us go with the second equation for Q1. For Q1, if I want to derive an equation for Q1, what are the incoming edges? Q0 with input, Q0 with input A is the first equation. There is no other incoming edges for Q1, so that we can make it as this is the second equation. Let us go with third state, that is Q2. Let us go with Q2. Q2 equals to, what are the incoming edges which are coming for Q2? That is A, B and even self representation. That is Q0 with B plus Q1 with A plus Q2 with A. Let us assume this is the third equation. There are three equations. What do we need to make? We need to do that, simplify the equation using Arden's theorem and find a regular expression. We are going to convert this finite automata to regular expression, RE. Means here the input is finite automata, the output is regular expression. When we are making we need to concentrate only on to get out this finite automata to regular expression. The regular expression should be applied on final state. Here in this diagram, in this transition diagram, Q2 is the final state. Now if I want to apply Q2 equals to, here I am substituting 1 and 2 equation. 1 and 2 are substituted in equation 3. Now we will get off Q0. Q0 value. What is the Q0 value? Epsilon. Already you have come across in identity laws. As per the identity rules, when epsilon equals to, it is equals to 1. Now epsilon equals to 1. Now we are applying Q naught into B, that is the Q naught into B. Q naught B is epsilon into B plus Q1 into A. Q1 value is Q naught into A and Q2 into A. Now again already you know epsilon value is 1. B into, what is Q naught value? Q naught already you know epsilon, which is epsilon is already you know, that is 1. A into A plus Q2 into A. Now if you go with this statement, now if you look into this statement, it looks like R equals to Q plus RP. If you look into this. Now if you write, if you know R equals to Q plus RP, which is nothing but your Arden's theorem. Now you can write it as Q2 equals to, you can write as Q P star. Q value is B plus AA into P star. P star is your A star. Now the regular expression for this statement, R equals to B plus AA into A star. This is a simple way how to convert a finite total media to regular expression.